let's talk about oversampling. So question 3 is ask you to prove this one. I'm gonna do this in the lecture, during the lecture this week, so I will not do that, but I just introduce this equation so you can use it to do number 4 and number 5. Okay, so this is a one sampling frequency. This one multiplied with a 2 to the order of B1 is how many bits of the ADC is. Okay, you can think of if you have a large number of bits you can use, probably you can sample a little bit slower so you can get the same result as a regular, like a Nyquist sampling frequency and a certain bits. Okay, you can see how this works in the following questions. So question 4, an audio system handles signal with a base band that extend to 20 kHz. Okay, the largest frequency is 20 kHz. Using a 12-bit converter, determine the oversampling ratio. Okay, oversampling ratio, and the minimum sampling frequency that will be necessary to achieve the performance that would be obtained within 16 bits. Okay, so first we have a two set of setting or sampling rate and bits. They are pair, right? So one is fs1. So this sampling rate is gonna pair with b1, which is we got a 16 bits here. Okay, and the first rate we got sampling rate we got a 40k, which is just the double, the barely minimum. Okay, double the highest frequency, Nyquist frequency. All right, so we know that a B2 we're gonna use a 12-bit. So the questions ask you what is the frequency you need to sample, like how many times more you want to oversample to get the same noise level as the first one. So we're going to use this equation. So that's 40 multiply with a 2 to the order of 2b1, and b1 is just 16 here, and equals to a number we don't know, multiply with 2 to the order of 12. Okay, so we want to divide that one in this side. So 40 multiply 2 multiply 16 divided by 2 to the order of 12 equal to fs2. So this division gonna equals to 2 to the order of 216 minus 12 equals to fs2. Okay, so this is a 40k. Okay, this is a 40k. So the fs gonna just equals to 40k multiplied 2 to the order of 8, right? Equal to fs2. So this question is actually asking you the oversampling ratio. So the oversampling ratio is just 2 to the order of 8. So this ratio is 2 to the order of 8 is 256 times. And if you times 40, that will be the frequency. Okay, so we use this equation. Question 5. Very similar. Signal with a bandwidth of a 4K is sampled at Nyquist rate, which is 8K, right? Double that, and digitalized using a 24 bits. Okay, this time we have a 4 times 2, 8K, multiply with, that was the fs1, multiply 2 to the order of 2 multiply with 24. And if we have 20-bit ADC now used, what is sampling frequency is required to do that? Okay, again, so has to multiply 2 to the order of 20. 2 times 20. So then we know that this one gonna equals to division, and so 8k multiply with a 2 to the order of 2 multiply with 24 minus 20. Okay, so again 4 times 2 is 8, 2 to the order of 8, 256. So fs just equal to 8k multiply with 256, and the answer is 2.048 megahertz. Okay, so that's question 5. So the conclusion we got is if you don't have large bit of ADC, you need oversample very significantly. Okay.